Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind adjust the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
At the Christ the King College, Onitsha, of the then East Central State of Nigeria of 1970, I was the rising star in physics and calculus. For that reason, everybody at Christ the King College, Onitsha, called me Calculus rather than Philip. At Christ the King College, Onitsha, my physics textbook was titled Advanced Level Physics. That physics textbook was co-authored by Michael Nelkon and Philip Parker. Those that knew me by the name Calculus at Christ the King College, Onitsha, Nigeria, we are not surprised that I won a scholarship that was dated September 10, 1973. That scholarship made it possible for me to arrive in the United States on Sunday, March 24, 1974. I spent my first night in the United States alone. I spent that first night in 36 Butler Hall, Monmouth, Oregon. An earlier turning point for me as a mathematician was in June 1970 at age 15 inside a bookstore near Dennis Memorial Grammar School, Onitsha, East Central State, Nigeria. The bookstore was a short distance from Zeke's Roundabout, Onitsha. Inside that bookstore, I paid the then unheard of £1.05 for a 568-page blue hardbound book that was titled An Introduction to the Infinitesimal Calculus. The calculus book was subtitled with applications to mechanics and physics. The calculus book was written by G.W. George William Count and published by Oxford University Press. The frontier of knowledge of physics, calculus, and algebra are the intellectual salts that I used in my supercomputer quest for the then uncharted territory now known as the massively parallel processing supercomputer. That terra incognita of knowledge is where the fastest supercomputer exists and where I discovered how to harness my ensemble of processors as the building blocks of a new supercomputer. That new supercomputer is the precursor to the modern parallel processing supercomputer. I discovered how to harness those processors to solve extreme scale problems in algebra that arose in computational physics. I was the first person to witness the world's fastest algebraic computation that occurred across a new internet that was a global network of 65,536 processors. I witnessed that fastest algebraic computations at 10:15 a.m. New York time, Tuesday, the 4th of July of 1989, the U.S. Independence Day. That experimental discovery represents a new paradigm in the history of algebra. At first, I couldn't believe my fastest algebraic computations, and I believed that I had made a mistake in the manner I operated the internal timer that I used to time the speed of my new supercomputer. Everybody said I had made an embarrassing mistake, but everybody was embarrassingly mistaken. At my mathematical core, I'm also an extreme scale algebraist. It made the news headlines in 1989 that I, Philip Emeagwali, discovered how to solve the largest system of linear equations of algebra and how to solve them at the fastest speeds but with the slowest processors. What I contributed to extreme scale fast computational mathematics was the cover story of top publications in mathematics. I discovered how to reduce the toughest problems in calculus to their acceptable approximations in algebra. I discovered those algebraic approximations as the most extreme scale problems in computational algebra. That mathematical discovery led me to the most computation-intensive problems in floating-point arithmetic that I could only solve by first discovering how to massively parallel process and how to do so across my small copy of the internet. That's a global network of 64 binary thousand processors. Let's put my mathematical discovery in historical perspective. The quadratic equation of your high school algebra had one unknown and two solutions, just as the quadratic equation x squared equals 9 has the two solutions -3 and +3. And your high school small-scale algebra textbooks didn't go beyond a system of 3 equations that had to be manually solved for 3 unknowns. But today, I am wondering, how can I massively parallel compute a system of 1,000,000 billion trillion equations of algebra and do so to compute at the fastest speeds for answers that comprise of knowing 1,000,000 billion trillion unknowns? That's impossible to scribble across all the blackboards in the world. That's impossible to store within one motherboard. I discovered that massively parallel supercomputing may make it possible to someday solve for 1,000,000 billion trillion unknowns and help discover and recover otherwise undiscoverable and unrecoverable oil and gas. More than half of the oil and gas discovered in Nigeria are unrecoverable. Around the world, thousands of oil fields have been abandoned because more than half of the oil and gas are unrecoverable. The Alleviates oil field of the Niger Delta region was Nigeria's first oil field. The Alleviates oil field was discovered in 1956 and began production in 1958. The Alleviates oil field was abandoned in 1978. The Alleviates oil field was abandoned 20 years after it was discovered. The Alleviates oil field was abandoned with about 70% of its oil and gas deemed unrecoverable. My application of extreme scale algebra in extreme scale multi-physics scenarios of petroleum reservoir simulation is the most important application of algebra in Nigeria. Algebra is an instrument of poverty alleviation.
Insightful and brilliant lecture.